Our sixth lesson in this chapter is dealing with the Pythagorean theorem, which I believe is something that you saw back in 8th grade. So this should be review, but if not, we'll take a few minutes and just kind of go over it and review a little bit. So with the right triangle, you have three sides, like any triangle. You have two legs, and then you have a hypotenuse. And we've already talked a little bit about the hypotenuse this year when we proved right triangles congruent using hypotenuse leg. But just to review one more time, your hypotenuse is the longest side of your triangle, and it's also the side that's across from the right angle. So in this picture, C is our hypotenuse. And then the other two sides are going to be the legs. So in the picture, we could say that a squared plus b squared equals c squared. But c squared always has to be your hypotenuse, and it always has to be off by itself. So the way that I usually think about the formula for Pythagorean theorem is leg squared plus leg squared equals your hypotenuse squared, and then you know exactly where things have to go. All right, so with this one, solve for the missing side of each of the following right triangles. So in the first one, we have a right triangle. First thing I usually do is I find the hypotenuse. And in this case, that's what I'm trying to solve for. That's what I'm trying to find. And I know the sides that are the legs. I know this side is 5, this side is 12, and I have to find the hypotenuse. So my formula is leg squared plus leg squared equals hypotenuse squared. And then I just plug in what I know. I know one of the legs is 5, I know the other leg is 12, and I'm trying to find the hypotenuse. And so I can just go ahead and try to simplify this. 5 squared is going to give me 25. 12 squared is going to give me 144, and that's going to equal the hypotenuse squared. And now I just add together the 25 and the 144, and I get 169 is equal to the hypotenuse squared, but I need to get the hypotenuse by itself. So I have to undo squaring the hypotenuse. And to undo squaring something, you take the square root. And remember, whatever you do to one side, you have to do to the other. And now with this one, we end up with the square root of 169, which is 13, and the square root of h squared is just h, so the hypotenuse in this triangle is 13. All right, the second one's a little bit different because this time we know the hypotenuse. In this case, the hypotenuse is 20, and then one of the legs is 12, and the other leg is what we're trying to find. So when we plug in this time, we know one of our legs. I'm just going to write my formula. We know one of the legs is 12. The other leg is what we're looking for, and I'm going to call that x just because that's what I labeled it in my picture. And my hypotenuse is 20. So 12 squared is 144 plus x squared, and that's going to equal 20 squared, which is 400. And now we have to do some subtraction. So we're going to take 400 and subtract 144. And when we take 400 and subtract 144, we get 256. And then we have to take the square root of 256. So when we square root both sides, the square root of 256 turns out to be 16. So the missing leg is 16 in this case. All right, and really that's all that can happen with Pythagorean theorem. Basically, with Pythagorean theorem, you know two sides of your right triangle and you're looking for the third. It doesn't matter which two sides you know and which one you're trying to find. If you think about your formula, leg squared plus leg squared equals hypotenuse squared, then you can go ahead and plug in. Just make sure you put the things in the right spot. All right, so sometimes what will happen when you're using the Pythagorean theorem is you'll get answers that are not perfect squares. And so you'll have to simplify your radicals. So what I will do is I'll walk you through how to simplify radicals kind of quickly, but I'll also put another video in MathXL, which will walk you through how to simplify radicals. So if it's something that you don't remember how to do from algebra, then that video should help, and it will walk you through it a little bit slower than what I'm going to do in the video today. So for this one, we want to solve for the missing side of each of the right triangles and write your answer in simplest radical form, as well as rounded to the nearest tenth. So we want to write our answer two ways. We want it to be in simplest radical form, which means keep the radical around it. And then we want to type it into our calculator and round it to the nearest tenth. So on this triangle right here, my hypotenuse is that side, so I'm given the two legs. So leg squared plus leg squared is equal to my hypotenuse squared. And then I just go through and solve. So 5 squared is 25, another 5 squared is 25, and that's equal to my hypotenuse squared. And now I add the 25s together and I get 50 is equal to the hypotenuse squared, and now I have to square root that. Now, one thing that you can do to check and see your answer is if you type it into the calculator, you're going to get a decimal. It's not going to turn out to be a nice perfect number. You're going to have to round it at some point, and so when that happens, then you know you want to go back and look at the problem and decide, do they want it in simplest radical form or do they want it rounded to the nearest tenth? In this case, they want both. So to simplify a radical, what you have to do is find a perfect square that goes into 50. So your perfect squares are 4, because 2 times 2 is 4, 9, because 3 times 3 is 9, 16, 4 times 4 is 16, 25, because 5 times 5 is 25, and 25 goes into 50, so I'm going to use that one. So 50, I can rewrite it as 25 times 2, and the reason that I picked 25 times 2 is because 25 is my perfect square. And if I take the square root of 25, I get 5. And now 2 is not a perfect square, so that has to stay under the square root sign. So in this case, in simplest radical form, the length of the hypotenuse is 5 times the square root of 2. So that would be simplest radical form. Now, to get that value rounded to the nearest tenth, all you have to do is type either the square root of 50 or 5 times the square root of 2 into your calculator, and you'll get a decimal. So if we type in the square root of 50 into our calculator, we end up getting 7.071 whatever, and so rounded to the nearest tenth, that would be about 7.1. So I could say, or 7.1 is about the length of our hypotenuse. So we have our answers in simplest radical form, and we have our answer rounded to the nearest tenth. All right, same thing over here, but this time our hypotenuse is 8, and we're looking for one of the legs. So leg squared plus leg squared is equal to the hypotenuse squared, and now we can just go through and clean it up. We have x squared plus 16 equals 64, and now we just have to subtract 16 from 64, and so we get x squared is equal to 48. Now, if you take the square root of 48 on your calculator, you get a decimal, which is about 6.9. So we know one of our answers, rounded to the nearest tenth, x is about 6.9, but we also have to simplify it. So we have to find two numbers that multiply to 48, but one of them has to be a perfect square. So if we take 48 and divide by 16, we get 3. So 48, I can rewrite it as 16 times 3. 16 is my perfect square. So my hypotenuse, or my leg in this case, is going to be equal to 4, because the square root of 16 is 4, and then the 3 is not a perfect square, so it has to stay underneath there. So the length of that leg is 4 times the square root of 3, or rounded to the nearest tenth, it's about 6.9. All right. So again, if you're having a hard time simplifying radicals, I will again post another video in MathXL, which will walk you through it a little bit slower in case it's something that you haven't done for a while. All right, so on the back, let's take a look at a couple of word problems, like real-world examples. With exercise number 3, it says a 12-foot long ladder leans against a wall such that it is 4 feet from the base of the bottom of the wall. As shown, how high up the wall does the ladder reach? Round your answer to the nearest tenth. So I'm going to call this x. That's the thing I'm looking for. I'm going to find my hypotenuse, and then I can plug into my formula. So one of the legs squared plus another leg squared is equal to our hypotenuse squared. And so we'll just clean it up. X squared plus 16 is equal to 144. And now we have to subtract. So I'm going to take 144, subtract 16 from it, and that gives me 128. So x squared is equal to 128, and now I have to square root both sides. And when I square root 128, I get 11 point something. And so I go back and I look at the problem, and it says round your answer to the nearest tenth of a foot. So I know I don't have to simplify the radical, I can go with the decimal. And so in this case, x is approximately equal to 11.3. And we do have units here, so 11.3 feet would be about the length of that wall. All right, exercise 4, we have an equilateral triangle that has a side length of 10 inches. So we have an equilateral triangle, all sides are equal, and they're all 10 inches. What is the area of the triangle in simplest radical form? So area of a triangle is 1/2 base times height, and the base and the height have to meet to form 90 degrees. So basically what we have to do is Pythagorean theorem to find the length of that height. So if this is an equilateral triangle, we know that the altitude is also a median, so it's cutting those sides in half. So that's 5 and that's 5. And so we can do Pythagorean theorem to find the length of that leg if we look at 1/2 of that triangle. So leg squared plus the other leg squared is going to equal our hypotenuse squared, and now we can just clean it up. So at this point I have to subtract 25 from both sides, so I get x squared equals 75, and if I take the square root of that, I know that 75 is 25 times 3, so that's going to be 5 times the square root of 3, which you could use as a decimal. But in this case, they did say that they want our answer in simplest radical form. All right, so again, always go back and look at what they're looking for with the problem so that you know how to keep your answer. So now we can find the area. The area of that triangle is 1/2 the base of the triangle, which is 10, times the height of the triangle, which is that 5 times the square root of 3. And now we can just go through and multiply. 1/2 of 10 is 5. 5 times 5 is 25, and that's all times the square root of 3. So this is 25 times the square root of 3 is the area of that triangle. All right, we can also use the Pythagorean theorem in the coordinate plane or on a graph, which is going to actually help us with tomorrow's lesson. This one tells us that we have a line segment drawn. We want to find the length of that line segment. So we can take this line segment and actually turn it into a right triangle. So if I draw a line from A straight across, and I draw a line from B straight down, all of a sudden I've created a right triangle, and now I can use the Pythagorean theorem. I can find the length of this segment that goes horizontally from A to B. That is 1, 2, 3, 4, 5, 6, 7, 8 units long. And I can find the length of this segment that goes from B down, which is 1, 2, 3, 4, 5, 6 units long. And now once I've done that, this right here, the segment I'm looking to find the length of, that's all of a sudden the hypotenuse of my right triangle. And so now I can use the Pythagorean theorem. One of my legs squared plus the other leg squared is equal to the hypotenuse squared. And then we can just clean it up. So we get 64 plus 36 equals x squared, and when we add those together we get 100, and so 10 is going to be the length of that segment there. I guess I kind of did that in the wrong spot. We drew the horizontal and vertical lines, and then we found the length using the Pythagorean theorem. All right, so hopefully that refreshes your memory on Pythagorean theorem. If you haven't seen it before, again, just make sure you know the formula, know where the legs are, know where the hypotenuse is, and it should be okay from there. Other than that, simplifying radicals is something that you do have to be able to do. So if that was a little tricky for you, make sure you watch the other video because I will be asking you to write some of your answers in simplest radical form.